Okay, so the next thing that we're going to do, our next conversion factor, is going to be moles to liters or back and forth. So remember that this has to be a gas, okay? And liters is a measurement of volume. So we're measuring volume of gas. So the conversion for this is always going to be 1 mole is equal to 22.4 liters, okay, or 22.4 L. I don't know why I spelled that out. Okay, so when we're working these problems, we can just be asked, okay, so we can be asked how many moles of oxygen are in, let's say, 25 liters. Okay, so of course the first thing we do is have our given. So we started with 25 liters, that's our given of oxygen. Okay, we also find our goal. So our goal is the question, how many moles of oxygen? Okay, and so then we just need a conversion factor to go from liters to moles. And we know that the conversion factor for this is 1 mole over 22.4 liter because of this conversion. Okay, and any conversion factor we can flip the way that we write it. So we could write 22.4 liters over 1 mole. Doesn't matter. Okay, so every time we're going to start with what we're given. So we're going to start with 25 liters of oxygen. And of course, that's not our goal, so we have to multiply it by some type of conversion factor. So if liters of oxygen is on top of this imaginary 1, then I need to put liters of oxygen on the bottom of the next fraction. So this is a conversion factor, so it has to stem from one of these two fractions. Okay, so liters, 22.4 goes with liters, and this is equal to 1 mole of oxygen. So that makes the liter of oxygen cancel with the liter of oxygen, and the only thing we have left is mole of oxygen, which is our goal. So we say equal mole of oxygen. So in our calculator, all we do is say 25 times 1, if you want to use that 1, and then all that's going to be divided by 22.4. So it's basically just 25 divided by 22.4. So let me do that math in my calculator. And I get, not multiplied. 25 divided by, and I get 1.11607, blah, blah, blah. Okay, since this is 2 sig figs, I'm just going to keep 2 sig figs. So this is roughly 1.1 moles of oxygen. Okay, I could also go the opposite direction. So I could have asked you for how many liters are in a certain amount of moles, and all you would have done is just flipped this conversion factor because you would want liters, so you would want liters on top. Okay, so that's how you do that. Let's talk about how to do multiple steps. So let's go into multi-step problems. We've done like 1 or 2 of these, but they look complicated, but as long as you follow your rule of what you have needs to be canceled out. So if you have it on top, it needs to go on bottom, or if it's on bottom, it needs to go on top, then you will be able to follow through your multi-step problem. Okay, it's also important to use conversion factors at every step until you get to goal. So an example of this would be, we can use the same type of problem. So instead of saying how many moles of oxygen are in 25 liters, I can say how many, let's do atoms of oxygen are in, same number, 25 liters. Okay? So again, every single time I'm just going to write what I'm given. I'm given liters of oxygen, so 25 liters of oxygen. And then I'm going to write my goal. My goal is how many atoms of oxygen. Okay, so normally we say, what is a way to go from liters to atoms? And we normally just have one step right here, so one conversion. But we really don't have anything that goes straight from liters to atoms. But we can go from liters to moles and moles to atom, okay? Because since there is no, there is no conversion straight from liters to atoms, we have to do this multi-step problem, okay? And that will take me from liters to atoms. Okay, so every single time we're just going to start with what we're given. So I'm going to start with 25 liters of oxygen. And since that is not my goal, I have to multiply it by some type of conversion. So if liters of oxygen is on top, I need liters of oxygen to go on bottom. And remember, this has to be a conversion factor. So it has to be something that I know. I know that 22.4 liters is equal to 1 mole of oxygen, okay? So that gets rid of liter of oxygen, and now I have mole of oxygen. Well, that is not my goal, so I'm here. I need to go one step further and go to atoms. So again, I'm going to multiply by a conversion factor, and since mole is on top, I want mole to go on bottom. And since I'm trying to go from moles to atoms, I can say 1 mole is equal to 6.02 times 10 to the 23rd atoms. Okay, and these are all oxygen. So then moles of oxygen cancels with mole of oxygen, and the only thing I have left is atoms of oxygen. Okay, I have my numbers, so I have 25 times 1 times 6.02 times 10 to the 23rd divided by 22.4. So I have all my numbers still, and the only unit I have is atoms. So I'm finally at my goal, and I can write atoms oxygen. So my calculator is going to look like this. Everything is kind of on the same fraction bar. So you're going to multiply by the top and then divide by the bottom. So it's going to be 25 times 1 times open parentheses 6.02 times 10 to the 23rd, close parentheses. You can do this multiple ways. If you have a cool calculator, you can make this a big fraction bar, and this can be all the numerator. If not, I recommend solving for the numerator and then dividing that by the 22.4. Okay, so either way, whatever you want to do, it's still going to be 25 times 1 times 6.02 times 10 to the 23rd divided by 1 times 22.4 times 1. So if you do all that in your calculator, it gives you, hold on one second while I work it, 25 times 1 times 6.02 E23 divided by 22.4. My calculator gives me 6.71875 E23. Okay, we don't want all those crazy digits. All I need is 2 sig figs, since 25 is 2 sig figs. So I'm going to stop it here. So my answer should be 6.7 times 10 to the 23rd. So I'm going to go put this back up here. Okay, and that is the answer to the problem.